Chapter 8 is about a thing called quadratic equations. So 8.1 is going to be all old stuff, and therefore hopefully easy stuff to lay a little bit of foundation for tomorrow, which is all new stuff. Doesn't mean it's hard. I don't think it really is hard tomorrow, but it's new. It's something you've never seen before coming tomorrow. First thing I should explain, since the whole chapter is about a thing called quadratic equations, I should tell you what that means. A quadratic equation just means it has an x squared in it as its highest power. It also probably has an x, and it probably has a number, but sometimes, as you'll see when we progress through the board, my next column has the x's are all missing. My last column has those numbers all missing. Those are still quadratic equations because they all have x squared. But most of the time, they have x's, they have numbers, they have other things. You've solved these since Algebra 1. We've solved these on and off all year in Algebra 2. Nothing we're really doing today is news, other than it just sort of like gets us warmed up for a bridge to tomorrow. So for this, how would we solve this from our experiences?
Make it equal 0.
Make equal 0. So your general operation here is get it equal to 0. So we'd have an x squared. When the 5x crosses over, it would be minus 5x. When the 6 crosses over, a plus 6. Our first move is generally get that equal to 0. Then what are we trying to do?
Factor.
Factor. So this one, I'll splotch the XX. Minus and minus. 2 and 3. Does anybody need a factoring seminar reminder? We factored a ton, chapter 5. Positive 2 is an answer. Positive 3 is an answer. Anybody need a seminar on how we got the answers, how we factored, how we did any of that? So much fun. Let's do it again. So this first move.
Make it equal 0.
Make it equal 0. So when the 10 comes over,
Minus.
So 6x squared, 11x,
Yes.
then factor. The way I've always done this is guessing. Mrs. Walters has a whole other scheme. You could visit her sometime and see it.
No.
But she's been dealing with the Algebra 1. But
I agree.
I've always been the guess check kind of guy myself. But it works. It's true. It's valid. It takes the guesswork out of it. But
Takes longer.
you might be right. For you, some people are more secure in it.
I've always just learned it this way now.
You just look at it and just
Guess somebody.
go with 3 and 2.
I'd go 3x, 2x. It's not impossible. It could be 6x, 1x, but I've probably trained you over the years. You only go that 6x, 1x.
So if it's big.
Like if this is a real big middle, we might have to do that.
Yeah.
So if we were needing to get 60, we'd have to partner a 6 with a 10 to do that. But since this is kind of medium size, we're probably going to want to go medium size.
Yeah.
Sides?
Plus minus.
Plus minus, and that is, we don't really know where they're going. We are just needing to guess there. I generally steer clear of the 10-1 option.
You want to go 5.
I'd go 5-2. 2 can't go here. Why can't 2 go there?
Even over the.
Because if these are both evens, that would make this an even. We need to balance out our even odds. So also if we put a 2 here, we could take out a GCF of 2. But back here we weren't able to take a GCF out. So don't create a GCF scenario now. Find the GCFs up front. So probable 5, probable 2, and then we'll FOIL the check. This is a positive 4. This is a negative 15.
Switch the signs.
So it's making a negative 11. The only thing we guessed wrong is the signs. And if you're like making educated guesses, you're not really guessing. And I prefer to do that. But that whole thing from Singapore, she imported, it's true. So what's the answer from the first factor?
2/3.
2/3. We can make a fraction there.
5 halves.
Close.
5 halves.
Negative 5 halves. Question about that pair? This one is a little bit more of a monstrosity because to even get there, you're going to have to do some
Foiling. Or
distributing. So 2x squared
Minus 3, 6x.
minus 6x minus 4x squared minus 4x. While we're at it, we might as well go minus an 8 so it can equal 0. Cleanup time, x squareds, negative 2, x's, negative 10, 8, negative, that equals 0. Then what do you think first when we try to factor this that we haven't done today, but we've done about 1,000 times before? Common factor. We can take out what common factor? I would go even a little bit more than just a 2. I'd go a negative 2. I don't like to factor with my leading coefficient being negative. If your leading coefficient is negative, take off a negative, because what will that do? Make all the signs switch, and in this case, they're all going to be positive. But while we're doing that, might as well grab the 2 also. So x squared
Minus 5x.
Or plus 5.
plus 5x
Plus 4.
plus 4 xx
4,
Pluses.
pluses
4, 1.
4 1 answers
Negative 4,
Negative 4, negative 1.
negative 4 negative 1. The fact that we took this out in terms of the answers does
Nothing.
nothing. If we took an x out, that would do something.
0.
0, but that didn't happen. Question about those, none of that's really new. We've done that. Like I said, this is all things we've done before. We're just trying to bridge into tomorrow. Question so far? Here's why we need a bridge into tomorrow. This scheme works on every problem on the board. It works on every problem on this homework. It doesn't work on every problem in the universe. Does anybody have a thought on why we can't count on this to work on every problem in the universe?
OX.
I could go back here and use my eraser and chalk to make like a small change and just blow this whole thing up. Can anybody think of a way that I could make a change here and the whole thing just blows up?
Oh, you can't factor them?
Can't factor. Not everything in the world factors. Okay, you've been spoiled because the book sets you up in all your factoring sections that things factor because it's practicing factoring. Okay, but if I go in here and make this a 7, you can't factor it. Okay, 8, 9, 10, 11, 12, pretty much any number other than like 6 and 4. You're stuck. You can't factor it. There's very few numbers that could go here to make this able to factor. The majority of numbers are unfactorable. So tomorrow we cover the point of what happens to the vast majority of problems in the universe where factoring can't work, because you can't count on that all the time. And that's what tomorrow's about. Then I'm going to Ohio Thursday, Friday. The videos are already up. People that are in classroom, the sub will show you the videos. People that are in Ohio, watch the videos yourself. If you want to work ahead some, after we do tomorrow's lesson, the videos will make sense. But if you tried to watch the videos tonight, they wouldn't make any sense yet. Okay? Today kind of bridges us with a warm-up to tomorrow, which is new. You can't understand 8.3 or 8.4 until you've seen 8.2 happen. So stay tuned on those. If you're an Ohio goer, wait till you've seen 8.2 before you even try to look at 8.3, 8.4 videos. Question about first option? Okay, second option gets easier. A lot of times my notes, they get harder as we go. Today gets easier as we go because the problems get smaller. Sometimes you don't have the x term. These problems just have the x squared part. They have the number part. There's no xiness. There's no middle piece to these. So I'd go about solving these a different way. Does anybody have a thought on how to solve this without getting, you don't need to get it equal 0. You don't need to factor. We're going to go around that. Anybody have a thing you could do to solve this? Say what? Eventually, yeah. We're going to want to do that with the goal being to get to x squared 11. So goal is, let's get the x squareds alone. So divide by 4 is right, that'll get us 3. And then how can we solve from that spot? Do the root. So this would be root of 3. That's half the answer. X squared equations almost always have 2 answers. We were getting 2 over there. This also has 2. We got one of the 2. Plus or minus root 3. Okay. When you do the root, it's plus or minus whatever answer you're getting. So here, get the x squared alone. X squared would be 4. Do the root. 2, but not just 2. Plus or minus 2. Which, if you'd rather write it this way, you can. Either of those circled answers is equally acceptable. We get double answers because negatives times themselves have to turn into positives. So the negative and positive versions of those answers are equally good. This one, the x squared would equal 8. So if you do the root of 8, 2 root 2. Does anybody need me to run the seminar on how we simplified those roots to get stuff like 2 root 2 out of rooting 8? And then why is that not perfect yet? Plus or minus that. Question about that. So there's 3 different scenarios. Sometimes you get a root you can do. Sometimes you get a root where you're stuck. Sometimes you get a root that it simplifies. No matter what though, bring the plus or minus with you. This, if we get the x squared alone, what would x squared end up equaling if you do 2 moves of oppositeness? Negative 6. What's going to happen when we do the square root of negative 6?
Can't go positive.
Not necessarily. I's come out. There's going to be something with i's. If you drop this problem on an Algebra 1 student, they'd say impossible and move on because they don't know about i's. But after chapter 7, if we're rooting negatives, i's are alive in this chapter. We will continue to root some negatives. We will continue to pop out some i's. So what about i's? By who? It would be I root 6. And then to make a perfect answer?
Plus minus.
Plus minus. Question about that part of the world where the x wasn't there and we were doing roots. Oh, I got one more up here. Never mind. Went too soon. For this, if we got the x squared alone, what would you do first here?
Subtract the 1.
Subtract the 1. So we'd be looking at a negative 1. Then how would this get out of there? Divide. Divide, make fractions. Flip. So we'd have a negative from the 1.
49 over 36.
49 over 36. And then we're trying to do the root of that.
7 over 6.
7 over 6 is involved.
Plus or minus.
Plus or minus is involved. I is involved. Anytime we root a negative, make sure we get our i's re-involved in life. Question about that before I cross the next line. Okay, if there aren't any numbers, we've been there, done that on these. We are going to get these equal 0. We are going to factor. How do these factor a little differently than the factoring where we came in?
Take out a GCF.
Take out a GCF, which in every single problem is going to be
X.
x. So factor x as a GCF. So take off an x, leaves you
X minus 10.
x minus 10. Answers
10.
and
0.
0. 0 will
Always be an answer.
always be the one answer. And there will be a second answer as well. So here we take off again x, leaving
4 minus
4x minus 11.
agreed,
So 11 over 4.
11 over 4,
0.
and guaranteed 0 for this whole column. This,
2x.
I would take off a 2x to leave
X minus 5.
x minus 5. So answer options,
0 and 5.
0 and 5. And that's what we're doing. The only thing that's even slightly new is the i's being alive. I mean, I is not new to your life. We did that all through chapter 7. But the i's coming out in this context is new to you, I suppose. But we've definitely factored GCFs to get these 0 answers. We've definitely done some roots before to get some plus or minus answers. We've definitely had the standard factoring before to just get the 2 normal answers. But today is just trying to build up some momentum into tomorrow. Tomorrow, what's going to happen is some of them will still continue to factor. They'll still blend those in. But the vast majority tomorrow will not factor. So you need another tool in your toolbox. If factoring fails you, there's another thing that we'll learn about tomorrow that gets you out of the hot spot. Question about what this is about from 8-1. There's like 25 minutes. I would guess this might be doable in 25 minutes for the faster type people of the classroom. We're skipping 3s. And we're working to 45, which technically is a 3, so I guess it's the 44. So working to number 44, skipping the 3s. It's about 30 problems. You have about 25 minutes
What
left.
page?